Camera slowly pushes in on. Lena, 30s, quiet, ex-music journalist, sits.
Take a deep breath. Imagine you are at the helm of a state-of-the-art starship, its cockpit a symphony of holographic displays and quiet, humming machinery. Your mission, a culmination of humanity's boldest ambitions, is to journey to the most enigmatic and formidable object in the cosmos. You are flying to the edge of a supermassive black hole, a gravitational titan lurking in the heart of a distant galaxy. This isn't just a trip across space, it's a voyage to the very boundary of reality, to the universe's ultimate point of no return, where the known laws of physics are stretched to their absolute limit. After a journey that has crossed unimaginable voids, you arrive. You establish a stable, though precarious orbit just outside the event horizon, the invisible membrane beyond which nothing, not even light, can escape. From your viewport, you witness a spectacle that defies all earthly description. A swirling, superheated disk of gas and dust, the accretion disk paints the darkness with incandescent colors, a cosmic whirlpool spiraling towards oblivion. You see the light from stars behind the black hole bend and warp, creating ghostly rings and distorted images. This is gravitational lensing on a colossal scale, space itself contorting under the black hole's immense gravitational pull. For what your ship's chronometer registers as a few hours, you are a silent observer to this cosmic ballet of creation and destruction. Your scientific objectives complete, you fire the engines and begin the long journey home. As you travel, you try to re-establish contact with mission control, but the familiar voices are gone, replaced by automated signals and archival data packets. A growing sense of unease settles in. When you finally arrive in Earth's solar system, the feeling turns to shock. From orbit, the planet below is a tapestry of shimmering lights and structures you've never seen. Continents are reshaped and vast, glowing networks connect cities that seem to span entire landmasses. You have returned home, but it is not the home you left. Centuries of human history, progress, and change have flashed by while you were away. Your world, your time is gone, leaving you a relic in an unrecognizable future. In this bewildering new reality, one truth becomes terrifyingly clear. You have traveled through time, not with a fantastical machine but as an unwitting passenger on the currents of space-time itself. This isn't a paradox from a science fiction novel, it's a fundamental consequence of our universe, predicted over a century ago by Albert Einstein. His theory of general relativity revealed that time is not a constant, universal clock ticking at the same rate for everyone. Instead, time is interwoven with space into a single, four-dimensional fabric, space-time. And this fabric is not rigid. It can be bent, stretched, and warped by the presence of mass and energy. Imagine space-time as a stretched rubber sheet. A planet like Earth creates a small dimple, a star creates a deeper one. But a black hole, with its immense mass crushed into an infinitesimal point, creates a gravitational well so deep it's practically a puncture. The closer you get to this well, the more severely space-time is curved. And according to relativity, the more gravity curves space-time, the slower time flows. Near the black hole, the distortion was so extreme that your time was slowed to a crawl relative to the rest of the cosmos. For every single minute that passed for you, years, decades, or even centuries were ticking by on Earth. You were in the ultimate slow lane of the cosmic highway. And here is the most profound and unsettling part of the experience. From your perspective, everything felt completely normal. Your heart beat at its usual rhythm. The ship's clock ticked away the seconds with perfect regularity. You aged at a normal rate. Time, for you, was consistent within your local frame of reference. You had no physical sensation of it slowing down. It was the universe outside your window that was accelerating into a frantic, high-speed future. You were an island of slow, steady time in a raging river of cosmic history. While you were making a log entry or checking a sensor reading, entire generations were being born, living their lives and passing away back on Earth. This journey to the edge of a black hole, therefore, reveals one of the most fundamental and mind-altering truths of our existence. Time is not absolute. It is relative, malleable, and profoundly linked to the structure of the universe. It flows at different rates in different places, shaped by the dance of gravity and motion. Black holes are nature's ultimate laboratories, extreme environments where these bizarre effects are put on full display. Your journey has made you a ghost from the past, a living testament to the fact that the cosmos operates on principles far stranger than our everyday intuition can comprehend. The universe is not just stranger than we imagine, it is stranger than we imagine. Time is not just a measure of change, it is a dimension you can travel through. For centuries, we thought time was universal. This was the cosmos of Isaac Newton, governed by an absolute clock ticking at the same rate for everyone, everywhere. It was a steady, unchanging backdrop, a constant river flowing in one direction, completely separate from space. This was the bedrock of classical physics, a simple, predictable, clockwork universe. But at the dawn of the 20th century, a young patent clerk began to question this fundamental truth. Through brilliant thought experiments, Albert Einstein imagined a reality where the speed of light was the only true constant. Then Einstein shattered that idea, and with it, our entire conception of reality. The age of relativity had begun. He revealed that space and time are not separate. Instead, they are inextricably linked, showing space and time are woven together as space-time, a single, dynamic, four-dimensional fabric. This isn't a static stage for events to play out on. It's an active participant in the cosmic dance. Every object has its own unique address in this grand continuum. With this new framework, Einstein offered a radical new definition for gravity. Gravity, he realized, wasn't a mysterious force. It is the warping of this fabric by massive objects. Imagine a heavy bowling ball on a stretched rubber sheet. It creates a dip, a curve. A smaller marble rolled nearby simply follows that curve. That is what an orbit is, following the curvature of space-time. But this warping doesn't just bend space, it distorts time itself. The closer you are to a massive object, the deeper you are in its gravitational well, and the slower time passes for you. This is the mind-bending phenomenon of gravitational time dilation. It means time literally runs slower for someone on the ground floor than for someone on the top floor of a skyscraper. On Earth, the effect is tiny, but real, with profound consequences for our technology. Take the global positioning system. The satellites orbiting high above us are in a region of weaker gravity. As a result, their onboard atomic clocks on GPS satellites tick faster than those on the ground by a net total of about 38 microseconds every single day. Without correcting for this, GPS would be wildly inaccurate. Navigation errors would accumulate at nearly 10 kilometers daily. Einstein's insight transformed our understanding of the cosmos. Time is not fixed, it bends and stretches with gravity. Our technology depends on this mind-bending truth. The universe's clockwork is far more intricate than we once believed. The movie Interstellar brought time dilation to life. Astronauts near a supermassive black hole experience hours while decades pass on Earth. This isn't just drama, it's real physics, guided by Nobel laureate Kip Thorne. The film's black hole visuals based on Einstein's equations even inspired new scientific research. Interstellar bridges science and imagination, showing how time's flow can shape lives and relationships. The universe's laws aren't just equations, they're stories that touch us deeply. Sometimes reality is more astonishing than fiction. Black holes remind us how much we have yet to discover. Black holes and time dilation spark wild theories. Could they be gateways for time travel? While science says you can't return to the past, orbiting a black hole could let you leap into the future. Some imagine advanced aliens using black holes to watch the universe evolve and fast forward. Others dream of civilizations surviving cosmic disasters by hiding near black holes, slowing time to wait out eons. These ideas are speculative, but they show our urge to find meaning in the cosmos. Black holes become more than destroyers. They're tools for survival, imagination, and wonder. Our stories stretch the limits of science, just as black holes stretch the limits of reality. The universe invites us to dream big. The allure of a black hole is undeniable, a perfect sphere of darkness against the tapestry of the cosmos. But to venture near one is to court cosmic annihilation. Get too close, and you'll experience gravity not as a uniform pull but as a relentless differential force. The part of your body closer to the black hole is pulled with unimaginably more strength than the part that's farther away. This is the brutal nature of tidal forces in the extreme. These forces will stretch you thinner and thinner like a piece of cosmic spaghetti. It's a process scientists aptly named spaghettification. You would be elongated into a single glowing stream of atoms, miles long, before you even reached the black hole's edge, and that edge has a name, the event horizon. It isn't a physical surface you could touch, it's a threshold, an invisible line drawn in space-time itself. Cross the event horizon and escape becomes impossible. This isn't because you'd need a faster-than-light ship, it's because space-time itself is rushing inward into the black hole's core, faster than the speed of light. Imagine being on a river flowing faster than you can possibly swim. No matter which way you turn, the current carries you toward the waterfall. Inside the event horizon, all paths in space-time, all possible futures lead to one place, the center. At that center lies the singularity. Here, our most fundamental understanding of physics completely breaks down. Both Einstein's general relativity and the laws of quantum mechanics fail, yielding nonsensical answers like infinity. It's a place where the universe as we know it ends. So what truly is it? Is it a point of infinite density and zero volume as relativity predicts? A physical impossibility that signals we're missing a piece of the puzzle? Or could it be a gateway? An Einstein-Rosen bridge, more commonly known as a wormhole, theoretically connecting our universe to another, or to a distant point in our own? Or is it something even more exotic, like a fuzzball of tangled energy strings or a Planck star that rebounds instead of collapsing forever? The honest answer is, we simply don't know. These profound unknowns are why black holes are the ultimate laboratories for the extreme. They are cosmic crucibles, testing the very limits of space, time, and the fabric of reality itself. They reveal the astonishing flexibility of time. Near a black hole, time dilates, stretching to a near standstill. To a distant observer, an object falling in would appear to slow down infinitely, forever frozen at the event horizon. They also present us with profound paradoxes that challenge our greatest theories. The information paradox, for instance, pits our two pillars of modern physics against each other. Quantum mechanics insists that information can never be destroyed, yet black holes appear to erase it from the universe. Resolving this conflict is one of the biggest challenges in physics today. The solution likely lies in a unified theory of quantum gravity, a theory of everything, that can finally describe the singularity. Deadly and mysterious, black holes are far more than cosmic destroyers. They are cosmic teachers, holding the secrets that could spark the next great revolution in science. For all that we have learned about them, black holes serve as a humbling reminder of how much mystery remains. They prove that the universe is still full of profound wonders, waiting for us to ask the right questions and, one day, to finally explore.